Hello everyone. So we're going to go over stoichiometry, get an introduction to it. First thing we're going to do, we're going to start off with reviewing balanced chemical equations because you have to have a balanced equation in order to do stoichiometry. And so we're going to review writing out balanced chemical equation of aluminum bromide and chlorine gas to form aluminum chloride and bromine gas. And so, first thing you want to do is write out your equations. Write out your formula for your equations. Okay. And so I'm going to start with the reactants. Of aluminum bromide and chlorine gas. All right. So we're going to have aluminum, and we're going to have bromine. Right. And so we have to ask ourselves what our charges are, and then do our crossover rule. And so aluminum's going to be +3. Br is going to be -1. And then when we do our crossover, right, so you're going to have AlBr3 for aluminum bromide. Okay. Actually, let me do that in the same color so we can keep our reactants and our products separate and color coded. It's going to be AlBr3. Okay. And chlorine gas is just going to be Cl2 because chlorine gas is diatomic. And so that's how we know it's Cl2. And so let's do our products. Okay. For our products, we have aluminum chloride and bromine gas. Okay. And so when we think about our charges, aluminum is +3, Cl is -1. So we're going to do our crossover. And so we're going to form AlCl3. Right, and bromine gas is just going to be Br2 because bromine is diatomic. Okay, and so let's write out our equation. I'm going to have AlBr3 plus Cl2 goes to AlCl3 plus Br2. And now we have to balance our chemical equation. True or false? You can change your subscripts. Is that true or is that false? That is false. You cannot change your subscripts. You can change your coefficients. Your subscripts you cannot change because it shows the type of bonding that's going on, and it also has to do with the charge of the atom. Okay, so we have aluminum. We have one aluminum on the left side. We have 3 bromines, and we have 2 chlorines. On the right side, we have 1 aluminum. We have 2 bromines, and we have 3 chlorines. Okay. Doesn't really matter which one you try to fix first. I'm just going to try to fix the bromine first just because that's the order I wrote it in. It doesn't matter whether you fix bromine or chlorine. The only time the order of which you balance things really matters is when you're dealing with a combustion reaction. When you're dealing with a combustion reaction, remember that's a hydrocarbon plus oxygen makes carbon dioxide and water. You want to try to fix your carbons first, and then your hydrogens, and then your oxygens. If you have to choose between hydrogens and oxygens, try to fix your hydrogens first. Okay. But we're not doing a combustion reaction right now. That was just a little review. So let's balance this. Alright, so I'm going to fix my bromines on the right side. And I'm going to just say 3 times 2 is 6. And that's the nearest number that these two have in common, 3 and 2. So I'm going to put a 3 here. I'm going to make this a 6. Right? And I'm going to come over here. And I'm going to put a 2 here. And that's going to make this a 6, but that also makes my aluminums 2. So I'm going to fix that over here by putting a 2 here. That makes my aluminums 2. Both of those match. But now I have 6 chlorine, right? And so I have to fix that over here. I have to make this 2 into a 6. I'm going to do that by putting a 3 here. And now I have a 6. So I have 2, 3, 2, and 3. And that is my balanced chemical equation. Okay. And so that'll be your answer. So on to what is stoichiometry. Stoichiometry is a way of determining the recipe of chemicals in a reaction. So if it takes 2 slices of bread and 1 slice of cheese to make a grilled cheese sandwich, how many sandwiches can I make with 6 slices of bread? Okay. And so if I have 6 slices of bread, right, and in 1 sandwich, right, takes 2 slices of bread, my units, so to speak, slices of bread cancels, and I'm going to sandwiches, right? 6 divided by 2 is 3. I can make 3 sandwiches. Okay, 3 sandwiches. Now let's change this question a little bit. If my bread, 1 slice of bread weighs 5 grams, and I have 50 grams of bread, how many sandwiches can I make? And so here we're going to have to go from grams to slices of bread to sandwiches. Alright, so if I have 5 grams as my given, 5 grams of bread. Oh wait, that's not right. I have 50 grams of bread. Oops, try it again. I have 50 grams of bread. That is my given, 50 grams. Okay. And 1 slice is 5 grams. Now I've gone from grams to slices. Right, I've done this here. Now I have to go from slices to sandwiches. Right? And so it takes 2 slices of bread per 1 sandwich. Okay. So here I have gone from slices to sandwiches. And keeping up with your conversions, that looks terrible. Keeping up with your conversions is really important with stoichiometry because you're going to have, this is called the fence method, you're going to have fences that are a bit longer than this. And so understanding what you have to convert to and keeping that straight is very important. I can't not emphasize the importance of that enough. Okay. And so let me make sure my units are canceling. I'm going from grams of bread, right, to slices of bread, and then from slices to sandwiches. I want to end with sandwiches because it's asking me how many sandwiches can I make. Okay. And so we're going to have, multiply across the top, we have 50. Divided by the bottom, 5 times 2 is 10. And we can make 5 sandwiches with 50 grams of bread. This is a bit more of what stoichiometry is going to be like, except we're going to be using a balanced chemical equation. Okay? And that's for space for you to write out your own answers if you use the slides as notes. So, in a similar way, we're going to be converting from grams to moles of reactant to moles of product. So like we went from grams to slices to sandwiches, now we're going from grams of reactant to moles of reactant to moles of product. Okay. We can also calculate the grams or moles of another reactant if there's 2 reactants. Okay. And so, when we read a balanced chemical equation, why does the equation have to be balanced? Well, the balanced chemical equation shows us the recipe. Okay. So, this equation tells us that you need 2 moles of potassium combines with 1 mole of chlorine gas to make 2 moles of potassium chloride. And so here's our recipe, so to speak, like we did with our grilled cheese sandwich. Alright, like we had our 2 slices of bread plus our 1 slice of cheese. In this particular case, it makes 2 moles of our product, but in our last case, it would have made 1. Okay, so if I have 5 moles of potassium, how many moles of potassium chloride can I make? Alright, and so, how are we going to do this? Well, we're with the slices of bread, right? I started off with my given, which was 50 grams of bread. This was my conversion factor. Each slice of bread, the weight of each slice of bread was a conversion factor. Okay. Our given is what you want to start with. So my given, all right. So let's write out first. We're going from moles of potassium to moles of potassium chloride. All right. So I have 5 moles of potassium. Let's take that out and just put potassium. I have 5 moles of that. Okay. That's my given. My recipe says that I need 2 moles of potassium for every 2 moles of potassium chloride. Okay. And that's all. Okay. We only had to go from moles of potassium to moles of potassium chloride, and that's what we've done here. So we went from moles of potassium to moles of potassium chloride. All right, we multiply across the top and divide by the bottom. So we're going to have 10 over 2, which equals to 5 moles of KCl, potassium chloride. Okay. Now this is similar to the question of where I proposed I have 50 grams of bread and each, slice weighs 5 grams. How many sandwiches can I make? We're doing a similar thing here. If I have 240 grams of potassium, how many moles of potassium chloride can I make? So I have to go from grams of potassium. I have to then go to moles. You have to go to moles because moles is what is given here. Okay, your coefficients represent moles. So you have to go from grams of potassium, 2 moles of potassium to your moles of potassium chloride. Okay, and so my given is 240 grams of potassium, right? I know that 1 mole of potassium, oop, I wrote that in the wrong place. I have to put grams in the bottom, right? 1 mole of potassium, according to the periodic table, is 39.098 grams of potassium. Okay. So here I'm going from grams to moles. Okay. So I can't use my balanced equation yet because, or until I cancel out grams, which is what I'm doing here. Okay. So now I have to go from moles of potassium to moles of KCl, and this is where my balanced chemical equation comes in. Okay. So what do I know from my balanced chemical equation? Well, it takes 2 moles of potassium to make 2 moles of potassium chloride. And if it seems like, well, I don't see where I'm going to be able to tell what number to use when and when exactly to convert. Stoichiometry takes a lot of practice, and I know I say that about everything in chemistry, but up to this point we've been doing a lot of background information. Stoichiometry is where we really start calculating things about chemical reactants and products, and so the accumulation of all that background information is important. It's important to practice all that so you can get to this point. The best way to practice in any chemistry class, or to understand, is to practice over and over and over again. Okay, then you'll start seeing patterns, and so if you need to watch more videos besides this one, watch more videos. But when I started doing stoichiometry, when I took it in high school, I definitely didn't understand it. I didn't try to take the time to understand it, which really bit me in the tail when I went to go take AP Chemistry the next semester because I didn't know what in the world was going on. If you have to take Chem 2 or anything beyond, this is very important to understand. So, it's important for you to, if you're not understanding, to ask questions and to watch other videos. So anyways, we've converted 2 moles of potassium, and now we're going from moles of potassium to moles of potassium chloride. Okay, so moles of potassium to moles of potassium chloride. Okay, so we multiply across the top and we divide by the bottom. So we're going to have 480 all over 78, and that gives me about 6.15 moles of potassium chloride. Okay. Using the same problem, if I have 5 moles of chlorine gas, how many moles of potassium chloride can I make? So we talked about in previous problems potassium as a reactant. And here you might be asking, well, why didn't we talk about chlorine before? When it asks you about potassium, it's assumed that you have enough chlorine with that number of moles of potassium to make your product. Okay? So here we're focusing on potassium. Here we're focused on chlorine gas. Okay, so just work with whatever reactant that they ask you to work with. So I'm going to go from moles of chlorine gas to moles of potassium chloride. Okay, So, we know that this is understood to be a 1. We don't write the 1. For whatever reason, the chemistry gods decreed that 1 is a obscene number that they don't want to see unless they have to. Whatever. But we're given, so you start off with your given, of course, as we have been doing. So we're given 5 moles of chlorine gas, right? And now we have to go to, we know for every 1 mole of chlorine gas, should be putting Cl2. Okay, we have 2 moles of potassium chloride. And it's as simple as that, because we have gone from moles of Cl2, I should say, to moles of KCl. And we had to use the balanced chemical equation to do that. You have to start with your given. You have to put your given in moles if your given is not already in moles. And then you have to use your balanced equation to find moles of your product. Now, if it asks you for grams of product, you have to take your moles of product and then convert it to grams. Okay? But here, we're just going from moles to moles. So nothing wild or crazy here. And so you can make, oops, I didn't write that out all the way. We got 10. So we're going to get 10 moles of KCl. Right? So this should say, with 200, didn't we solve this already? 200. Ah, I see what's going on. Okay. So before, I said how many moles of potassium chloride can I make with 240 grams of potassium? This problem is asking you to take these 6.15 moles and convert it to grams. Okay? So we already solved 6.15 moles. Okay. I think that should say potassium. Yeah. So this should say potassium. All right. So 6.15 moles of potassium chloride. And we have to convert that to grams. Because we already, now if we hadn't already solved for it, you'd have to solve all the way for it. But now we're just going from moles of KCl, because that's what we already calculated, to grams of KCl. Okay? So, 1 mole of KCl, or potassium chloride, is going to be your mass from the periodic table added together. All right, you multiply across the top, divide by the bottom. You have 458.47 grams of potassium chloride. Okay. So we're going to balance and solve this stoichiometry problem. We're going to need to balance first, which is why I left some room, and then we'll have the stoichiometry problem on the next slide. Okay? So, for our reactants, carbon, hydrogen, oxygen. Remember, this is combustion reaction, like I was talking about earlier. And so you want to try to fix your carbons first if they're not already fixed, and then fix your hydrogens, and then fix your oxygens. Excuse me, I have 3 carbons on the left, 1 on the right. I have 8 hydrogens over here, 2 over here. I have 2 oxygens over here, and 3 over here. Okay? So let's try to fix our carbons. Right. We want to make this a 3. And now we have 6, 7 oxygens. Okay. But we're not going to try to fix those yet. We're going to try to fix our hydrogens first. And our hydrogens, we have 2 over here and 8 over there. So we're going to put a 4 here. That's going to make this 8. That's going to make this then 10, right? Because we have 3 times 2 is 6, plus 4 oxygens is 10. Okay. Well, now we just have to fix our oxygens. And we're going to put a 5 here to get a total of 10 oxygens over here. And our equation is now very happily balanced. Okay. And so, how many moles of CO2 are produced with 0.75 moles of C3H8 reacting with oxygen? Okay. And so, again, start with your given. Okay. You have your moles of C3H8. And we need to go to moles of CO2 because that's what they're asking for, right? And so our given, we're going to start with our given, 0.75 moles of C3H8. That's our given. Once we have our given in moles, then we're going to use our balanced chemical equation because remember our balanced chemical equation is in moles. And so with moles, I know that 1 mole, right, because this is understood to be 1 mole of C3H8 reacts with how many moles of CO2? 3. 3 moles of CO2. Okay. You multiply across the top, divide by the bottom, so you're going to have 2.25 moles of carbon dioxide. Okay. Now we're going to go from moles of carbon dioxide to grams of carbon dioxide. So we already have our moles here. So we're going from moles of CO2 that we solved for in slide 14 to grams of CO2. Alright. So we had 2.25 grams of CO2, and converting from grams to moles means we're just going to use the mass from the periodic table, right? And so 1 mole of CO2 is your carbon plus 2 times your oxygens. And we're going to get 99.02 grams of CO2. So here all we did was take our moles from our last problem and convert it to grams. That's all we did here. Okay. Now, let's take this one step further. How many molecules of CO2 are produced with 0.75 moles of C3H8? And so, molecules involve Avogadro's number. The easiest way to convert to molecules is to use moles. Remember, 1 mole of anything equals 6.022 times 10 to the 23rd atoms or molecules. In this case, molecules because CO2 is considered a molecule. So, we want to go from moles of CO2 to molecules of CO2. So, we already had our moles of CO2, right? 2.25. So let's go back to our 2.25. Alright. And remember, 1 mole of anything is 6.022 times 10 to the 23rd. In this case, molecules. Right? So you should get 1.36 times 10 to the 24th molecules of CO2. Right? So this is just a little introduction to stoichiometry. Go back and practice the problems on your own is my suggestion. Okay. Also, I would suggest, I know like it can be a bit challenging because this seems very intimidating. It seemed intimidating to me when I first started in high school, but watching some Khan Academy videos and things like that can really help you to start seeing the patterns to help you solve these problems.